Hi friends, today we are going to discuss another distributed design pattern called singular update queue. Now what is singular update queue? Let's suppose you have multiple processes or you have multiple services that want to do some work, but they want to do it serially. For example, first one thing is done, then another thing, then another thing, then another thing. We have to maintain the order of execution. And when we want to do this in a distributed system, be it distributed via threading, be it distributed by multiple processors, be it distributed by multiple systems. Now, in that case, what we have to do is we have to ensure that all of them are sending it to a single queue. But before understanding this pattern, let's understand what are the other ways of doing it. Let's say this work that we have to ultimately do for each request that is being sent by the processes is some heavy lifting work. Let's say we want to write to a particular file. Let's say we have a file in which we want to write something. Now, the file is I, and if we want to ensure that each of them is writing serially in the order of their request sequence, how it can be done? One of the ways it can be done is we have a lock. We take a lock. Anyone who wants to write to this file will have to take a lock, and once they have written, they are going to release the lock. And once, for example, P4 is writing and it has taken the lock, and at the same time P3 comes to take a lock, it is going to be denied. So P3 will have to wait till P4 has written to the file. Now this mechanism, though practically possible, but it is not practically feasible, because each of these processes, if they are doing some important work, they will have to hold their processing just so that they can do some work in a serial fashion in a distributed system. So let's consider other ways of doing this. Let's say we have this, we have to do this work, and they are sending their packets in the queue. All they have to do is they have to send the packets in the queues. They can be multiple processes, threads, distributed systems. Now we will have a single doer. Doer can be a thread, doer can be a single system, which is going to consume from this queue, and then it is going to do the work. Very simple. Send your messages in the queue. There is going to be a single doer or single system that is going to do the processing on that queue, and it is going to do the work. This ensures that your work is done serially. For example, first 1, 2, 3, 4, then the work is going to be done 4, 3, 2, 1. Doer is going to do them one by one. What are the examples of this? One of the best examples for this is in distributed systems, you will learn about write ahead logs, wall entries, where before doing any work, you have to commit that to a particular file, so that even if your system crashes, your work is persistent on the disk, and when you are recovering from that crash, you can read from that log file, write ahead log file. This is going to be covered in another video whose description is going to be in the links below. So coming back to write ahead log file, each of them have to commit their entries to a log file. Now this can be done using this singular update queue method, where anyone who wants to write, any thread, any system, any process wants to write to a single write ahead log file, what we have to do is we have to send all the updates in a queue. There is going to be a single doer that is going to do the work, and the work in this case is committing the entries into the write ahead log file. This helps, this is efficient in comparison to the lock mechanisms of writing to that file, because the processes won't have to block themselves just so that they can write to the file. They can just send the message in the queue, and the doer is going to do the work. And if they want to receive the response, what we can do is we can have another queue where when the work is done, the doer can publish that message in the queue, and there's going to be another doer which is going to send the responses when it receives the messages. Or it can be a distributed system also. You don't have to have a single doer. It can have multiple doers, because you just want to inform the callers that their work has been done. Now this pattern, singular update queue pattern, is used in multiple systems. It is used in Zookeeper, it is used in Kafka, it is used in etcd. Everywhere this pattern is formed, is used. I'm not going to go into depth of how they're used, because it will extend the scope of this video. I hope you enjoyed this video. Thank you and have a nice day.